करने को बोल रहे हैं। नहीं, अमल तो आपको करना ही पड़ेगा, तो फिर गड़बड़ा जाएगा। कभी भी नहीं, हम बिल के लिए कभी नहीं बोलते।
Good evening, everyone present here.
हेलो।
इंट्रोड्यूस करा दीजिए हमारे ऑफिसर। हाँ हाँ हाँ, ठीक है, ठीक है। अभी चार नहीं दूंगा.
Good afternoon, ma'am. Rama, ma'am. Am I audible?
Yes, sir, you are audible.
Okay. So we are just a minute ahead. Okay. Now, so welcome to all the participants in our 5th online training on computational pedagogy. We have with us Rama ma'am, and I'm this resource person. So I request her to kindly start the session.
Thank you, sir.
Your
Thank
voice
you,
is
everybody
not
present
clear.
here.
Please come closer to the speaker.
Yes, sir.
The voice.
Voice is not clear now.
Uh,
Is the voice clear?
yeah, now it's okay.
Okay. Thank you. So, good evening, everyone present over here. Yet another session. Thank you to Himanshu sir. Thank you to Aryavat Sahodaya for giving me this opportunity. And this is another wonderful session on the very, very important topic. But I think last week only, you are, this week, I don't know, you have done one training session, and that was on computational thinking and computational skill. Now, this particular training session is on computational pedagogy. It's not only what is computational skill, but it is actually how we are going to impart this computational skill to our students. And before going to any further details, first of all, we should reiterate, we should remember Is it visible? Sir, I think it is visible now. Am I visible? Am I audible?
Yes. You are
Yes,
visible
yes.
but not clearly audible.
Yes, yes. Actually, there was a power cut, so it happens.
Audio is not clear.
Yeah, thank you. Thank you. So what I was talking about, that was what is pedagogy. We all know that it is a method and practice of teaching. Again, I will tell you that it is a method, not a method and the practice. It's an art. Pedagogy is an art. It serves as both an art and, of course, an applied science. And when we talk about pedagogy, it encompasses instructional strategies, learning theories, and the interactions between educators and students to facilitate effective and holistic learning.
Yeah.
Yes, sir? Audio is clear, no?
Yeah, now it is okay.
Yes, yes. So, I have already told that pedagogy is the practice, it is the method, it's an art, it is an applied science, and actually, it's on the pedagogy that depends whether we are imparting to our students what we intend to do. Yet, computational pedagogy is very, very important. Okay, because whether our students will be able to understand or able to imbibe the skill of computational thinking, that will depend on our computational pedagogy. So it's very important. And there is a small difference between these two things. Now, why should they matter? What are these computational pedagogy? So if we talk, computational pedagogy is of course a pedagogical approach that integrates computational thinking and modeling into educational practices. It means that we are carrying to the classroom practices what we intend to imbibe in our students. So computational pedagogy aims to enhance students' understanding of complex concepts by using computational tools and methods. Now, dear educators, we need to remember that computational methods, it is not about computer. It is not about AI only. It's not about different languages of computer. It's about how we are looking at different problems or different challenges in our life. How to look at it and how to go for this problem solving. We all know when we talk about 21st century skills, okay, someone is telling that I'm not visible. Yes, I was not visible because this camera was not working. I'm trying to make myself visible, and I think now I'm visible. So what I was talking about, that computational thinking is not about computers. It aims to enhance students' understanding of complex concepts of life by using different computational tools and different computational methods. So this is an approach, and this approach is particularly beneficial in scientific education, in STEM education, where computational thinking is essential for problem solving, for innovation, for researches. And this computational pedagogy actually encourages students to think critically, to analyze the data, to develop the algorithm. And these are the skills which are increasingly important in today's digital world. We know actually nowadays it's very, very important to talk about data sciences, about data analysis, about problem solving, about critical thinking, about thinking out of the box. And that is why, as computational skills are important, computational pedagogies are also important, because these are the tools, these are the methods through which we are going to impart the computational skill. So in a complex and data-driven world, of course, today in today's world, the most important things are data. How we are looking at data, how we are going to find out what are the if there is a range of data, what are the similarities, what is a particular pattern, in what way these patterns can be reanalyzed, rearranged, and in what way they are going to help us in our problem solving. So it represents a way of thinking. Computational skills are actually a way of thinking and a way of looking at the problems. And it allows the individuals, it allows the students, it even allows the teachers and the adults to tackle different complex challenges effectively. These computational skills are not just for software engineers, they form a methodology for breaking down problem. If we look at any problem as a big problem, as a complex problem, it's of course we are not going to solve it. But if we can break down, if we can find what are the similarities, what is the pattern, and we can arrange the data, we can make them usable, we can understand them, we can design some clear solutions, then that is computational skill. It's a skill of problem solving using logical, algorithmic, and computational thinking. So again, computational skills are not about computers. It's a skill of problem solving. It's a skill of computing different things. It's a skill of looking at our data. It's a skill of understanding, recognizing the patterns, and it is a skill to arrange the available data in a usable form and to break down the complex problem into very, very simple, small steps, and then develop the algorithm and plan a solution. Okay. If we are talking about all this, we should know what is the importance in CBSE. Of course, it supports NEP 2020, and it is actually linked with coding, AI, digital literacy. But again, we have to remember that it is not equal to AI. It is not equal to coding. It is not equal to digital literacy, but it is the foundation stone of digital literacy or AI or coding. Not only that, it's a very, very important 21st century skill without which our students or us cannot survive in today's data-driven world. Today's era, where a 12-year-old school's project can involve training a simple AI model. A class 8 student can make a simple robot, or a class 8 student can can automate a repetitive task using no code tools. They understand the logic behind and they find a solution. From healthcare to agriculture, from research to science to technology to engineering, wherever you are going, even when you talk about pure mathematics or research-based subjects or even social science, computational skill, computational thinking, and computational pedagogy are very, very important. And this is exactly why this is incorporated in our new syllabus across classes 3 to 8 for the academic year to 2026 and 2027. And it's just the beginning. It is not the end. And this is not a subject addition. It is actually what we are calling it most future relevant reform in Indian school education in our generation. जो भी हम लोग कर रहे थे उसमें ये अगर नहीं करते तो बहुत कुछ अधूरा रह जाता. It's very important. It's not about computers again, it is about thinking. It is the ability to approach problems the way a computer scientist would have done. It's not by memorizing facts. It's not by writing a code, but by applying a structured set of cognitive strategies. It's a thinking process to solve a problem. The problem may be real, the problem may be digital, but it's the way we are looking at challenges, and it is the way we are going to solve our challenges. So, what are the learning objectives? If we are talking about the learning objectives, both of computational pedagogy and computational thinking, the objectives are to develop logical reasoning, to develop the creativity, to develop the problem solving skill, and of course, to integrate computational thinking, data science, and artificial intelligence into everyday teaching practices. I think some participants are waiting in the lobby, but I don't know whether I can allow them. I can only view. So if someone from Aryavat Sahodaya is there, please let in. Okay. It has become small. I don't know what to do. Yes.
Please continue.
Yes. Sir, is the PowerPoint visible?
Huh?
Is the PowerPoint visible? PowerPoint, is it visible?
Yeah, it's visible. Just make it in slideshow mode.
Okay. Okay. Is it okay now?
Yeah, it's visible, but not in slideshow mode.
Okay. Slideshow mode from the current slide. I was talking about the learning objectives. So, this is to imbibe or to instill the reasoning, creativity, and problem solving in our students, and of course, to integrate computational thinking and artificial intelligence into everyday teaching practices. It's not nowadays, this data science or computational thinking or artificial intelligence, your chat GPT, it has become a way of life. We cannot think of avoiding them in our everyday teaching practices. So it's better that we actually instill these skills in our learners. And not only that, we can also take help from these tools. Okay. It encourages interdisciplinary learning, because learning, it is not different subjects as we have seen in our childhood. Social science is a subject, history is a subject, geography is a subject, mathematics is a subject. There's no linkage between them. No. Nowadays, learning is a wholesome process, a holistic process. And so we need to go to interdisciplinary learning. If we are teaching social science, there also the mathematical methods or the scientific methods of data analysis can be used, and they can be used very effectively. And that is why we need to practice interdisciplinary learning. And CBSE is also stressing on the importance of teaching students the ethical and social implications of technology. It's not about using the technology, but how to be ethical while doing so. Nowadays, we are actually aware of different type of you can tell anti-social activities, cyber crimes. But when we are talking to our learners, or when we are imparting this computational thinking through our computational pedagogy, we have to sensitize them, and we have to stress the importance of teaching our students the ethical and social implications of technology, ensuring responsible use of AI in education. So when our future generation is going to use this, they're not going to use it in an unethical way. It's very much important that we impart the sensitivity and sensibility into them, so that they are the ethical, they will be practicing these teaching these skills in an ethical way. So again, computational thinking, what it is breaking problem into small manageable parts. So in line of the vision of NEP 2020, the CBSE has introduced a curriculum from class 3 to 8. It's about computational thinking, and it is about artificial intelligence. Artificial intelligence, you can tell it's a next and linked step, but the first step is computational thinking. And this curriculum aims at developing learners' ability to think logically. Sometimes when I go to classes, and sometimes when I actually love teaching, even I'm a principal for the last many years, but whenever I get a chance, I get into the classes and I speak to my students, and I tell that when you are practicing mathematics or science, it's nothing that you are just going to mug up some knowledge, or you are going to practice some and it's a stereotype thing. No, what it should do, this science subjects and this mathematics, and even now this computational thinking, it should inject, it should make you to think logically. You should, whatever you are thinking, whatever you are looking at, the logic should be clear to them. Your approach should be logical. And when you are going to solve the problem, first understand what is there in the problem, what are the steps we need to solve, and what can be the ways to solve it. So systematic thinking, logical thinking, analyzing it, critical thinking, thinking out of the box, understanding the ethical use, understanding the tools, whatever is there in our hand, all comes under this purview. And this aims to equip teachers with pedagogical strategies to integrate computational thinking and AI concepts across subjects. This should foster ethical and responsible and future-ready learning environment. What are the 4 pillars? Please, all our teachers and all our students should know these 4 pillars. They are very, very important. What are the pillars? For machine learning, for artificial intelligence, for computational thinking, the 4 main pillars are pattern recognition. I was talking about it. When we are looking at some numbers, we are looking at some data, the pattern should be visible. What is the pattern? And that pattern, in what way they can help us in solving the problem. Then algorithmic thinking. It's not thinking in a jumbled way. It's thinking step by step. This is the first step, this is the second step, this is the third step. The third step can have 2 outcomes or 3 outcomes. If we take this outcome, then what will be the next step? This should be the thinking process. And then decomposition. You analyze the problem, break it up into small bits, and abstract thinking. all these four are very, very important pillars of computational thinking. The first is pattern recognition. What is that? What is it? Finding similarities and trends. So it is the ability to identify the regularity. Suppose you are given some numbers 2, 4, 6, 8. So you know 2, if it is the first member of the series, the second member is 4, 2 plus 2 is 4, 2 into 2 is also 4. But when you go to the next one, 4 plus 2 is 6, 6 plus 2 is 8. You can look at it in this way. Otherwise, you can think 2, 1 ja 2, 2 ja 4, 2, 3 ja 6, and 2, 4 ja 8. So this can be one way of thinking. These are different ways of following the regularities, the trends. What is the relationship between the data? Okay. So this, when you talk about this skill, this is actually the basis of how machines learn from data. When you talk about AI, is AI thinking? No, they're analyzing the series. The artificial intelligence is actually analyzing the data available, and then it is working on the pattern recognition. And from this pattern, it's learning something. So machine learning algorithms are extremely sophisticated pattern recognizers. If you get back to the new books of NCRT, you will see this pattern recognition, and they are wonderful. I'm telling you. This is not rote memory type of thing. You see the new mathematical books, you see in what way they are actually preparing our students to recognize the pattern. For classes 3 to 5, this begins with simple number, simple shape sequences, and then we go to more complex situation. When we talk about algorithm thinking, it is again creating step-by-step solution. You cannot have a jumbled up solution of any complex problem. If the problem is there, first of all, you have to just break the problem into parts, and then you create the step-by-step solution. It's a step-by-step sequence of instruction to solve a problem. Whether you are making tea, when you are making tea, you should know that first of all, you have to boil water. Then you have to put the tea leaves in the in the pot where you are going to soak the tea. Then when the water is boiling, and you should know the ratio for 1 cup of tea, what is the how many teaspoonful of tea leaves you have to put in the teapot, and then at what temperature the water is to be poured on it, and for how many minutes it is to be closed, and then how you are going to strain it, then according to your choice, how you are going to add sugar and milk. So these are the steps. You go for any problem in your life, you go for any work in your life, you need to solve it bit by bit, step by step. So algorithm thinking is exactly that. That is skill of designing, the skill of designing, following, and debugging. Debugging means finding out the mistakes. This is the bridge between understanding a problem and writing a program to solve it. You are not always going to write a program, but you have to think it like that. And CBSE curriculum introduces these true grid movement puzzles. Okay, finding the shortest route across 4 shops. This can be a problem. Now, when you introduce them to challenges that AI systems like GPS navigation is routinely solving, how they are going to look at the problem, that is your algorithmic thinking. And decomposition. Decomposition means breaking up a complex problem into smaller tasks. That is decomposition. Okay, whatever task it is, it may be a practical task, it may be a task in your education, but it has to be divided into smaller and simpler tasks. So breaking a large complex problem into smaller and more manageable sub-problem, that is decomposition. And if you can do it, then the next step, algorithmic thinking and writing a solution step by step, that becomes easy. And at the higher level, students can tackle projects planning with constraints, resource allocation, multivariable scheduling. So it's not only a simple problem, there can be different constraints and how different constraints are to be overcome. All this comes into this particular pillar of decomposition. A class 7 exercise they're talking about, it might ask the students to assign tasks to 3 team members across 3 days using 5 independent constraints. And then they are going to take back their learning and their data, and they are going to analyze, and then they have to overcome the constraint. What is abstraction? That is focusing on relevant information. You have so many information, so many data in your hand, but you need to know what are the data which is of no use in that particular problem. उसको हटा देना है. And जो relevant information है, उसको use करना है. And that is abstraction. You have to identify what is essential and what is irrelevant. So it's the principle that makes this artificial intelligence system generalize from training examples to new unseen situation. From your past experience, you need to get information. From that information, you have to find out which information is relevant for this particular problem. And then from the past experience, you need to go for abstraction, for unseen situation, and you have to apply your experience. So CBSE exercises range from finding the odd one out in a set of shapes and to understand how the same value can be, see, here there's a number, the number 12. This number can be expressed as 12.0. It can be expressed as a binary number 1100. This can be expressed as a Roman number, that is XII, and that abstraction is what allows them to be treated. They are equivalent, but then what is going to be used in that particular problem, that you should understand, and that is covered by this abstraction. Okay. Logical thinking, of course. Without logical thinking, computational skill is impossible. You have to use your reason, you have to use your logic to reach the conclusion. So, whatever activities you are looking at, that can be a puzzle, that can be a riddle, that can be a coding, that can be a game, that can be a brain teaser. You need to analyze, and then you have to go for logical thinking. And these things, whatever are there on the screen, the puzzles, the riddles, the math games, the coding, the debate, they are going to stimulate your logical thinking, your logical brain, and you are going to think logically in your life. It's a practice. You need to instill this particular practice in your learners and also in yourself, using reasoning to reach the conclusion. Now, I was talking about algorithm. Before the algorithm, you should be able to design the flow chart. It's a type of diagram. It represents how the algorithm will function. This is the step-by-step processes. And a flow chart, of course, it's a solution model to a given problem. So when we are talking about flow chart, we must know that the flowchart advantages are communication. When you are speaking to your audience through a flowchart, then your communication becomes simpler and better, and it is actually as clear. It is diagrammatic, so you are going to portray the logic of the system. The analysis is very effective. The documentation is proper, and your learners, or you are going to be efficient code makers, and you can go for proper debugging and efficient program maintenance. So all this depends on whether you are able to make this algorithm and whether you are able to make the flow chart. So these two are very, very important parts of this computational thinking and computational skills. And also, when you are going to a class, maybe you are going to have some topics and subtopic, you should know where to start, what is next, what is next, and at the third step, what are the different sub steps, and that is also a flow chart. So whether it is in class or whether you are going to talk about the solution of a problem, it should be in a way where the algorithm is clear to you. The flow chart is clear to you. And when this is clear to you, you are going to be a better teacher, a better educator. Your learners will learn better and they will think better. They will think logically. Pseudocode, this is a key term. It is writing algorithm in a simple language. You are not going to go to write something in a machine language or some very, very complex, very sophisticated computer language. But pseudocode is you are writing this in everyday words in simple English, but the logic is clear. The flow is very much obvious. It's a rough draft for your program. Okay, so when you go for a particular language, whatever it is, maybe Python, maybe Java, maybe Unix, maybe it is C, C++, that has different types of syntax. But when you are going to write pseudocode, the logic is clear, the algorithm is clear, the flow chart is clear. You can use simple, plain English. It's not very much difficult even for a literature teacher or a social science teacher. We all can use it because I'm telling this is the logic. Logic is the focus, not the syntax. Okay, so it is language independent. It can be converted into any programming language. So the pseudocodes, we as educators, we need to know what are the pseudocodes, in what way we can impart, in what way we can teach our students how to write pseudocodes for any problem or for any process. Data and information, from the beginning, whenever we are talking about like data and information, we should know the difference. Data is some facts, some information which is not processed. But when you talk about information, it is processed, it is organized, it is meaningful. So actually what we do, we are going to convert data into useful information, find the pattern, find the logic, understand the information, and use the information by abstraction. Okay, so whenever we talk about a problem solving or a decision making or an understanding, so we need to know how to convert data into information. कभी कभी आप स्कूल में भी काम करते हो, आप बोलते हो कि अच्छा मुझे ये डेटा चाहिए. Suppose this is a data about the height of the students in your class. Maybe you are a class teacher, you are talking about, I want the data about the heights of my students and the weight of my students, the body weight. Now you tell to your sports teacher or you tell to your school nurse, she's going to hand over the data. Roll number 1, 5 feet 1 inch, roll number 2, 4 feet 9 inch, something like this. And the corresponding weights, it is 55 kilo, 45 kilo, something. Then how to use it? The data is there in front of you. How to organize? You have to organize it. कैसे इससे पैटर्न आप ढूंढोगे? आपके बच्चे जो है उसका हाइट वर्सेस अगर आप वेट करोगे, आपको पता हो जाएगा किसका हाइट ज्यादा है, किसका हाइट एज वाइज कम है, जिसका हाइट ज्यादा है उसका वेट ज्यादा है कि नहीं. इफ देयर इज एनी एनोमैली, हाइट ज्यादा है तो वेट कम है, देन द चाइल्ड इज सिकली, क्या हो सकता है मैल न्यूट्रिशन है. You need to look at the data in the usable form. You need to arrange them. You need to analyze them. You need to find the pattern. You need to find the logic. And this logic should be clear. That is why always when we are talking to our students, we tell कि tabular form में सजा के लेके आओ. नहीं तो इसका कोई कोई मतलब ही नहीं होता है ना. अगर सिर्फ डेटा है, डेटा का कोई मतलब नहीं होता है. डेटा को अरेंज करना है इन एन यूजेबल फॉर्म, and then you need to analyze, find the pattern, and you need to go for your usable information. What are the key difference? Data is raw, unprocessed. Information processed, meaningful. Data exists independently. It is not dependent on anything. Information depends on the data. Purpose, data alone cannot help you in any way, but information provides insight, the logic, and it supports us in problem solving, in decision making. Data can be only numbers, it can be only text, it can be symbol, but information is structured. It is often presented in tabular form, reports, charts, graphs, summaries. And by looking at it, you get to know a number of usable things. So a list of daily temperature, it is only data, but the weekly average temperature or the maximum minimum temperature or the trend analysis, that's the information. Okay. Coding basics. Coding basics, we know that for any code, there's a language, but before that, there should be a pseudocode. Here, there are some examples from Python. It's very much usable now. It's easy also. But before going for coding, you need to know about your data types. You need to know about syntax, the flow control, the functions and the procedures, and the reusable blocks of code which can perform specific tasks. Okay. Basics of coding, I think this is not under the purview here. Calculating the average of numbers in Python. You see the simple program. DEF, calculate underscore average numbers. This is the syntax. Total is equal to sum of numbers. Return total means the output is total divided by the number of numbers, and then you get the average. So calculating average is a function that takes a list of numbers, adds it to get the sum, and then divide it by the number of numbers and returns the average. This is a simple basic coding of Python. Okay. Block-based coding, when you talk about Scratch or similar platform, there is block-based coding. This is generally used for the students who are of smaller age, maybe 5 to 16. Users can create projects on the website using a block-like interface. There is text-based coding also. And now this is very important, that is debugging. Debugging is finding the mistake and correcting it. This is also a high-level thinking skill, because if you don't know where you have gone wrong, then you can never correct it. Just now, for some months now, I'm into Vedic mathematics. I have become a keen supporter and practicer of Vedic mathematics. To some of my children that from the very beginning, sometimes maths have become very troublesome for you. And one of the main problem in mathematics is that you never know whether your answer is correct. You are going to ask your parents, your teachers, your friends, मेरा आंसर ये है, फिर मतलब पन्ना पलट के लास्ट में देखना है आंसर की में क्या दिया हुआ है. We are not knowing, we are not confident about our answers, but there should be a solution to this. We should be knowing that this is the answer and this is correct. Okay, so debugging is a high level thinking skill and it is an essential component and it is related to developing computational thinking. What is the objective? How do children identify the existence of error? How do they locate it? What type of errors come out when you are going for coding? What type of error can be there? And what is the debugging process? That also comes under your computational skills. Now, problem solving cycle. From the very beginning, I was talking about that computational skills or computational pedagogy. It is all about problem solving. It's all about decision making. Now, when we are talking about problem solving cycle, in simpler form, we call it PDCA cycle. PDCA, plan, do, check, act. प्लान में आपका सब कुछ हो रहा है, आपका डिकम्पोजिशन आ रहा है, आपका एल्गोरिदमिक थिंकिंग आ रहा है, आपका फ्लो चार्ट आ रहा है, फिर आपका स्यूडो कोड राइटिंग, देन यू इम्पार्ट इट, डू इट, देन गो फॉर चेकिंग. जो आपने किया उसमें क्या मतलब कुछ भी एरर है, एंड दैट अंडर दैट कम्स योर डिबगिंग आल्सो, एंड देन यू एक्ट. उसको डिबगिंग करने के बाद फिर से प्लान करो. सो इट्स अ साइकिल. एंड इसको थोड़ा सा और बढ़ा के हम लोग इसको 5 पार्ट में बांट लेते हैं. इट्स नॉट प्लानिंग. बिफोर प्लानिंग you have to go to identify, you have to recognize the problem, you have to understand the problem, you have to understand the opportunity for improvement, and then you go for planning, for implementation, for check, and for act. So PDCA cycle can also be a little elaborated and can be talked about: identifying, planning, implementing, checking, act. Again, it's not only for your code writing, it's not only for computer, it is for your everyday life. Identify the problem, plan the solution for the problem, implement the solution, check whether the solution is working, and then act for improving it. So this is problem solving cycle, which encourages the learners or anyone to learn from evidence, to improve step by step, to turn the improvement from one-time project or from experience into a repeatable habit. कुछ solution लाने के बाद बैठ नहीं जाना है. It's in our thinking process. We should know कि कहाँ difficulties आ रहा है, उसको overcome करने के लिए क्या replan, rethink किया जा सकता है. So the cycle goes on, and it should be there in our brain. The PDCA cycle is easy to understand, but you need to actually apply it in your life. Utility क्या है? With an efficient problem solving method, you can solve many of your life issues, your individual issues, or at an organizational level. कुछ भी सामने difficulty आ रहा है, you can use your problem solving cycle and you can go for an effective solution. Computational skills across subjects. For us, for the educators, it's very important to know how we can someone is writing kya ho raha hai, some Harshit, he's writing kya ho raha hai. I think he has joined late or something like this. We are talking so much about computational skill, and kya ho raha hai agar samajh mein nahi aata hai to I don't know. Application in math. Of course, in case of math, computational skills, it refers to the ability to perform not only arithmetic operations, but for difficult operations also. When we are looking at any problem in mathematics, we need to know how to analyze it, how to decompose it, then what are there in our hand, and then how we can use them to solve step by step and reach our ultimate solution. So, a solid foundation in number sense, in recognizing pattern, in mathematical principle, such as associative approaches, commutative properties, these are essential for developing computational skill. Of course, in mathematics, we cannot think without this. Early exposure to counting to grouping to manipulatives like blocks or beads, एक ऑपरेशन, एक प्रॉब्लम, उसको क्या क्या डिफरेंट वे में आप सॉल्व कर सकती हो, किस में कितना टाइम लग रहा है, कौन सा सिंपल है, कौन सा कॉम्प्लेक्स है, जो कॉम्प्लेक्स है उसको सिंपल कैसे बनाना है, all comes under when you are using your computational skills pedagogy or your computational pedagogy in your mathematics classes. So mathematics is not going to the class, telling the formula, making the students memorize the formula and solving the problems which are given in the book. But it's more than that. आपके पास एक problem है, how you are looking at it. That is your computational pedagogy in your mathematics classes. Remember all my dear educators, आप mathematics teachers जो भी है, आप बच्चे को कैसे मैथ्स बनवा रहे हो या सिखा रहे हो, उसके ऊपर डिपेंड करते हैं क्या वो whether they are going to love maths or whether they are going to hate maths. मैथ्स जब वो समझ नहीं पाते हैं, पैटर्न समझ नहीं पाते हैं, रिकॉग्नाइज नहीं कर सकते हैं, डिकम्पोज नहीं कर सकते हैं, एब्स्ट्रक्शन के लिए नहीं जा सकते हैं, then only they are afraid of maths, otherwise not. So the procedural knowledge, the conceptual understanding is more important than solving it and getting the right answer. The answer is important, but not the most important thing. The steps are important. The thinking is important. The logic is important. So computational fluency, it extends beyond the basic calculation. And while you are going for this computational skill, they are often assessed based on speed and accuracy, and they are only one component of mathematical proficiency. To achieve the proficiency, learners must not master the calculation, but also must understand the purpose and how to apply the into the real world context. इसीलिए मैथमेटिक्स में कुछ सिखाने के बाद ना छोटा प्रोजेक्ट दे देना, उसमें बच्चा उसको अप्लाई करेंगे प्रॉब्लम सॉल्विंग में, एंड दे विल बी नोइंग द कंप्यूटेशनल स्किल्स. Now, when we are talking about science, modeling the system, the problem solving, the teaching and learning, the STEM education, all this depends on these computational skills and computational thinking. Okay. When we are talking about STEM education, it's a primary skill. It's a primary competency within the complex thinking. And not only the science teachers, of course, it's our duty, pious duty of science teachers and maths teachers to impart this computational pedagogy, but then it is across the subjects. So not only for researches or problem solving or modeling of a system or simulation, it's also for social sciences and for other subjects that we are going to use this computational pedagogy. Application in humanities, they are increasingly applied in social sciences, in digital humanities, in natural language processing. Please remember, NLP techniques are used to examine and extract data from massive textual databases, such as sentiment analysis, topic modeling, very, very new things. But these are important things, and these techniques can be used when we are going to use the computational pedagogy in our social science classes and in our humanities classes. So everywhere the data analysis is important, and these applications demonstrate the transformative power of computational skills in advancing the knowledge and addressing different societal challenges, societal problems in the field of social sciences and humanities. This is artificial intelligence literacy, and you can see that it is closely related with computational thinking, and you can see the different parts of the computational thinking, different parts and parcels of it, the digital literacy, the data literacy, the AI literacy, the procedural literacy, and all are cropping up, all are evolving from computational thinking. Okay, so they enable individuals to break down complex problems into manageable bits. Data analysis, I have told about these core pillars: the data exploration, data analysis, the data communication, and all the other things. Cyber safety. When we are talking about sensitization of our learners, about ethical use of artificial intelligence and data sciences, and when we are going to talk about the cyber security and data safety, so we are actually using the computational thinking. We need to know our students learn to apply the computational thinking skill. They should know how to go for decomposition of a problem, how they can understand the pattern, how they can go for abstraction and algorithmic designing, the pseudocoding, and other things. When we talk about ethical use, we should know the nuances, the logic behind it, and we need to analyze them, critically think about it in a different way. Collaboration and computational projects. We are talking about computational pedagogy. So it's always across the subjects. There can be team-based problem solving. There can be problem solving skill which can be imparted to them through a project where different subject knowledges can be imparted. So it is collaboration of computational thinking to uncover evidence for the connection between computational thinking and problem solving skill. We conduct a systematic literature review. Assessment strategies. When as teachers we need to go for assessment, we need to go for evaluation, we have to think about giving projects and conducting quizzes, conducting pseudo code writing tasks or coding tasks, the portfolio making. When we are giving these challenges to our students, we will be more equipped with computational pedagogy, and through this type of strategies, our assessment will be more enjoyable, and we are going to impart this computational thinking in a better applied and efficient way. Here we are talking about the core computational thinking. It's about breaking down problem. It is recognizing the pattern. It is designing the step-by-step solution, testing and improving outcomes, the debugging, and none of this requires a computer. This is, dear educators, we need to remember. Those who have spent 20 years, 15 years, 25 years of their lives in classroom without practicing computational thinking, they should know that they are already practicing it. They know how to break down problem, but we need to sensitize ourselves also that we don't need computer languages or computer knowledge. Only the thinking pattern should be logical, and we should know about it, and we should impart this thinking skill in our students. This matters even more today because this 21st century needs more sensitization and efficiency of computational thinking. What are the teachers' role? Incorporates computational thinking into the curriculum. That we have to do because CBSE has already told. And when you are going for STEM education, you cannot think without computational thinking and computational pedagogy. For professional development also, we should know more about them. To evaluate the computational thinking skill, we teachers should use various assessment tools. I have already told about the projects, the brainstormings, the algorithmic thinking, the flow charts, the debates, and other things. We need to promote interdisciplinary learning. By fulfilling these roles, we, the teachers, can effectively develop computational thinking in our students. So our pedagogy should be such that this particular type of logical thinking and problem solving technique can be instilled in our students. Our classroom teaching learning scenario should be like that. What are the challenges? The challenges are incorporating computational thinking in school, integration of computer technology and computer thinking in the school. There are several challenges. The digital divide, the teacher readiness is not there, the language barriers are there are funding constraints. But these challenges are actually, some of the challenges are in our mind. So they are compounded by the need for digital literacy. That's of course true. But first of all, the way we are thinking about our pedagogy, we are structuring our pedagogy, we are looking at computational skill, that should change. Not we should incorporate changes in everything the way we are doing it, but whatever we are doing, maybe we are practicing the same thing for a long time, but we are not knowing it. So it's better to know more about these computational pedagogies, and at the same time, we need to plan how to practice it in our classroom teaching learning scenario, how to make our students sensitize or recognize the patterns, the way they look at different data, the way they are changing the data into information, the way they are going to use the information in their everyday life for problem solving. There we have to overcome these challenges. So the best practices: integrate computational thinking across subjects. Of course, as school management or school principals or Sahodaya, as we are already doing, we are investing in teacher training. We are doing the same thing now even, and use engaging activities, incorporating puzzles, games, debates, real world problem solving projects, across the subject projects, focusing on competency based learning, participating in conferences, in workshops, in trainings, knowing more, reading more, applying more. These are the best practices. So we have to be future ready. We need to incorporate the problem solving skill, the adaptability and innovation should not only be in the students, but also should be in us. And we need to integrate the curriculum and integrate computational thinking into all the subjects like math, science, social science, humanities, language, and even art and music. It's the way we are looking at things. It's the way we are thinking about it. It's not a difficult or computer-based subject. So that we should know and we should think. So computational thinking is the new literacy of the 21st century. And as educators, we have to embrace it with proper and proper attitude. It's not like something कि मंगल ग्रह से आया हुआ कोई चीज नहीं है, ये हम लोगों में है, हम लोग इसको प्रैक्टिस कर रहे हैं, शायद हम लोग जानते नहीं हैं कि ये हम लोग प्रैक्टिस कर रहे हैं. So it's the way we are looking at it. So we need to embrace it as educators. We can never say this is untouchable for us. No, we have to embrace it with proper knowledge and attitude. With this, I will come to the end of the session, and thank you so much to all of you, to Aryavat Sahodaya, because for making a PowerPoint or for making a presentation, you need to learn a lot, and that helps you, that enriches you as a teacher, as an educator. So a big thank you to all of you. Thank you once again. Is there anyone? Himanshu sir? Simple ma'am? Anyone is there to conclude the session?
Thank you, ma'am. Thank you so much. It
Thank
was
you,
again an
sir. Thank you
excellent
for giving me
session.
a chance.
Yes. Last session we conducted on computational thinking, and this
Yes.
was the computational pedagogy. Really, the computational thinking and computational pedagogy have become an important feature of today's teaching learning. And the today's session was excellent one, as always, from your side. So
Thank you, sir.
I hereby thanks all the participants on behalf of Aryavata Saudya School Complex and you also
Thank you, sir.
for
Thank you so much.
for participating and taking this session this way. So I have already shared the feedback link for the attendance of the participants.
So, with your
Uh,
permission, may I?
yeah, so the participants may also register their attendance by 6:15 today. And you can leave now. Thank you so much.
Okay. Good evening and thank you once again. Thank you.
Thank you.